Hello everyone, welcome back to my YouTube channel, and in this video we will be talking about the interface segregation principle. This is the video of the solid principles topic, and this is the fourth solid principle where we'll be talking about interface segregation principle. Okay. Interface segregation principle is very simple. It states that a class should not be forced to implement the interfaces it does not use. Okay, see what we do normally with the interfaces is that we define the methods, and then all the classes which are implementing that interface need to make sure that they provide body for the methods defined in the interface. So let's say if let's take the example of batch epics. In batch epics we use the batchable interface, and because we use batchable interface we have to use the start, execute and finish method. We cannot omit any of these methods, we'll have to use it. So that's what interface does, is it forces all the implemented class to provide the method body. Okay, now there can be scenarios where let's say we do not use a particular method, but because we are implementing that interface we'll have to provide body. It kinds of sometimes becomes a burden for the class to provide the body for it, even if that class does not need that particular method. So that is the violation of interface segregation principle. It says that a class should not be forced. If it is required, then of course we'll have to, but it should not be forced. It should be we should create interfaces in such a way that we are not forcing those interfaces on the classes. Okay. Before telling you why or what are the advantages of using the interface segregation principle, let's try to understand it with the help of an example. Okay, so here for example I am creating a vehicle interface. Okay, I am trying to tell it with the real life example. Later on we will talk about a Salesforce specific example as well, but for the easier understanding I am trying to understand it with the normal real life example. Now let's say in the vehicle interface we have four methods. One is the start engine, one is open doors, one is wear helmet, and the fourth one is play music. Now from the method itself you can understand that all these four methods will not work for different types of vehicles. Let's say for bike we will have start engine but will not have open doors, will have wear helmet and will not have play music system. So for a bike only two methods are relevant, but if we use the vehicle interface we will have to provide the body for open doors and play music system method as well. Even if we have to provide the blank body, but we'll have to do that. That is a kind of forcing a class to definitely provide a body for a method, even if that class does not require that particular method. So that will be a violation of interface segregation principle. A better approach would be to create two different interfaces, one let's say for the two-wheeler vehicle and the other one for the four-wheeler vehicle. Okay, so in the two-wheeler vehicle I'll have, in that two-wheeler vehicle interface I'll have the start engine and wear helmet method, whereas in the four-wheeler interface I can have start engine, open door and play music system. So in that way I will be segregating the interfaces in such a way that we are not forcing those interfaces on the classes which are going to implement that. Okay, now why do we use it, or what are the advantages of having the interface segregation principle? See, it basically kind of simplify the complexity. If we do not need a particular method, there is no need to provide the body for it. It simplifies your code. Okay, it improves the flexibility, because here in the example itself you see that two-wheeler will have all the relevant methods related to the two-wheeler, whereas four-wheeler will have, in future we can have more methods which are just specific to let's say two-wheeler, or just specific for the four-wheeler. We can make it more flexible, we can add them according to the interface which is relevant to them. Reusability obviously will increase, because now we have a separate interfaces for separate use cases. Let's say in case in future we need a three-wheeler, we can have a different interface for that. We need not to add these methods and force all those classes to implement the irrelevant methods for them. Testability obviously will increase because testing becomes easier. Okay, you have to mock these smaller interfaces, you have to test the all the relevant classes and relevant methods only. Okay, and ISP basically encourage the separation of concerns as well, because things which is not relevant to you, you should not be even concerned about that thing. That is what ISP will try to implement. Okay, so this is what I was trying to say, that we'll have to split the interfaces into the smaller one. Okay, if I go back and show you the Salesforce instance, then we'll see. So if I show you this in the Salesforce instance, I have created an interface which is I record operations. This is basically used in the Salesforce org to do the create operation, update operation, close operation, and escalate operation. Now if we use interface and assume that, let's say, opportunity is going to use this interface. Okay, so let's say there is an opportunity processor that is going to implement this interface. Now opportunities we do create, we do update, and we do close the opportunity, but we do not escalate the opportunity. So that escalate method will be the additional for the opportunity. Similarly, for, let's say, account, we create account, we update account. So if there is a class which is a account processor which is implementing this interface, then the close method and escalate method will be the additional methods for that class, and that will be the violation of ISP. Okay, so I have to break my approach in such a way that I create the relevant interfaces. Let me split these interfaces into, let's say, I create createable one interface, I createable, which will have a method creatable. Okay, and save it. Then we'll have another interface, let's say I'll have to change it to interface first. Similarly, I'll have another method I updatable and change it to interface and put the body, save it. Then the third one, closable, maybe I closable, forget the spelling or ignore the spelling mistakes, guys. And the fourth one will be, let's say, I escalate. Okay, and we'll put the body, or we'll put the signature of method in it. Now instead of one big interface, I have separate reusable interfaces. Now let's say if I create the opportunity processor. Okay, now opportunity processor can implement I creatable, comma, updatable, and we do close opportunity, so closable as well. But we do not need to use the escalate method. Now we just need to provide the body for it. Okay, so creatable methods body, similarly body for escalate as well as update, sorry, body for close and update, not escalate. That is the whole point of not using the iRecord operation interface. Okay, so now you can see if we use the iRecord operations, we'll have to provide body for all the four methods defined in this interface, but we broke this interface in such a manner that we can reuse it. Even we can have a single interface for create and update, maybe later on add delete, and call it the DML operation interface, something like that. But for close and escalate, we need to have a separate interface, because close functionality we'll be using on opportunity, escalate we'll be using on cases. So when we create the handler or processor for cases and opportunities, then we can have it in this way. So by breaking the interfaces, we are increasing the flexibility and reusability in the system, as well as we are avoiding that situation where class has to provide body for a method which it does not even need. So that is the interface segregation principle for you. Do let me know your questions if you have any, in the WhatsApp group, or if you have my mail ID, you can just ping your questions there, and I'll be more than happy to explain it even further if it is not clear to you. And I'll see you in the next video. Thank you everyone.